Hello everyone and welcome back to our channel. If you are looking to master HashiCorp Vault, you have to come to the right place. Today we are kicking off an 8-part series that will guide you through the everything you need to know about HashiCorp Vault, from basic setup to advanced configurations for production environments. Let's briefly look at what each part of the series will cover. In the first step, we'll guide you through the installing Vault on a Linux system, ensuring you start on a solid foundation. Then, second step is we will dive into how to start and stop Vault server, focusing on both development and production environments. Third step is we'll focus on managing secrets. We'll learn how to read, write and delete secrets. And then fourth step. In the fourth step, we'll explain in the intricacies of secret path and engines, crucial for organizing your secrets efficiently. And in the step 5 is all about dynamic secrets, a game changer for automated access management. Then step 6 will cover token authentication method and integrating GitHub as an authentication source. Step 7 will detail how to create and manage access policy within Vault. And finally, step 8 will walk you through the deploying Vault in a production environment, ensuring you are ready for real-world application. Each video in our series is designed to build upon the last, gradually increasing in complexity and depth. By the end, you will not only understand Vault better, but also be equipped to use it effectively in any environment. Let's dive into our first topic, installing HashiCorp Vault. Installing HashiCorp Vault is straightforward, but it's crucial to follow steps correctly to ensure a securely and stable setup. We will go through the installation process on a Linux system. And don't worry, all these commands will be available in our GitHub repository, linked in the video description below. So let's move to our Linux terminal, and our first step is we will start by updating our package list and installing the necessary software for managing GPG keys. Open your terminal and type sudo apt update and sudo apt install GPG. Also, you can copy the command from my GitHub repository from here, and I will provide all the commands into my GitHub repository. So let's move to our Linux system and hit enter. As you can see, our package is updating. Now wait for it for successfully complete, and it will take us some time, so wait for it. Now it will successfully updated. Now our next step is we will add the HashiCorp GPG key, and this step ensures that the software we install is authenticated and secure. So enter the following command. So let's go to our GitHub repository and copy the command and paste over here and hit enter. Now it will successfully set up. It's always a good practice to verify the key's fingerprint to ensure its integrity. Run this command to check the fingerprint. So let's go to the GitHub repository. Copy the key fingerprints command and paste over here and hit enter. This command will help to check fingerprints and verify the keys of the fingerprints to ensure its integrity. Once the key is verified, let's add the HashiCorp repository to your system. This command will set up the repository. So I'll copy that and paste over here and hit enter. Now, after adding the repository, update your package list again and install Vault. So I'll copy the command and paste over here and hit enter. Then we will install HashiCorp Vault. So I'll copy the command and paste over here and hit enter. Now, as you can see, our HashiCorp Vault is successfully installed into our Linux system. So let's run command vault version to verify the Vault is successfully installed or not. As you can see, our Vault is successfully installed and its version is 1.18.1. And if you see the version number, congratulations, you have successfully installed HashiCorp Vault. That's it for today's video. You have just installed HashiCorp Vault on your system. In our next video, we will go through the how to start and stop the Vault server, including configuring it in dev mode, which is great for testing and development purposes. Check out our GitHub repository for all the commands we used today. And Join us next time to learn more about managing your secrets securely with HashiCorp Vault. And thanks for watching and see you in the next video. Hello everyone, welcome back to our channel. Now that we have installed HashiCorp Vault on our Ubuntu operating system, the next step is to understand how to start and stop the Vault server. But before we get into the commands, it's essential to know the two modes Vault can operate in. Vault has two main modes. First one is development mode. This mode is designed solely for development purposes and it's meant to run on development machine. Then second one is server mode. This is intended for production environments. And we will start by exploring development mode, which is perfect for testing and learning. To start Vault in development mode, use the following command and copy the command from our GitHub repository. So I will provide the GitHub repository link into my description box. Now I will copy the command and let's switch to the terminal where Vault is already installed. By running the command, Vault will be start in development mode. So let's go to our Linux terminal and paste over here and hit enter. Now you will notice an important note from HashiCorp. Development mode should never be used in production, as it lacks the security configuration required for a secure setup. Once your Vault server starts, there are four main components to understand. First one is port. The API address of Vault will be displayed here, indicating the port number Vault is running on. Second one is storage. So let's scroll up and you will see in the development mode, Vault uses in-memory storage, meaning all data is stored in memory and will be lost once the server stops. And also you can see here the port number, which is 8200. Third one is unseal key. Vault requires an unseal key to operate. Fourth one is root token. The root token is our admin access to Vault. And here is our root token. And here is our unseal key. You can see the components in the terminal output. Let's go over them one by one. First, look for the API address to find the port number Vault is using. Next is storage. In development mode, Vault default to the in-memory storage, which is not persisted. In production, Vault will be used disk or database storage, making it more secure and permanent. Next, locate the unseal key and root token in the terminal output. And here it is. These values are crucial, as the unseal key allows access and the root token is used for initial setup for administrative tasks. I will recommend copying these values to the notepad for easy access later on. So, our next step is to streamline working with Vault. Export these values as environment variables. So, let's open a new terminal and copy the command from our GitHub repository and paste over here. And make sure to replace port to your actual port number. In my case, our port number is 8200. Also, you can copy from the other terminal. You can copy the command and paste into the second terminal for export our Vault address. So I will hit enter. Now it will run successfully. So our next step is to export our Vault token. So I will copy the command and paste over here and replace the root token from our actual root token. So let's move to our first terminal and copy the root token and paste into the second terminal for export Vault token and hit enter. By setting these variables, you will be able to interact with Vault more easily. To verify Vault is running correctly, use the following command: Vault status and hit enter. This command checks Vault status and confirms if it's up. This command checks Vault status and confirms if it's running. A successful output means your Vault server is properly initialized in development mode. As you can see here, the status is initialized too. And that's it for today's session. You have now learned how to start your Vault server, understand its key component and check its status. In the next video, we will dive deeper into reading, writing and deleting secrets with HashiCorp Vault. Thank you for watching. See you in the next time. Hello everyone, welcome back. Today we will explore some essential operations in HashiCorp Vault, reading, writing and deleting secrets using the command line interface. Our goal is to understand how to enable paths, store, retrieve and remove secrets in Vault. Step by step, let's first go through our key commands and understand their purposes before moving into the live demonstration. The first command we will discuss is for writing data or storing a secret into a vault. This command allows us to secure store a key value pair. At a specific path, the command line is as follows. In the command vault kv put, this command tells what that we are using the key value engine to store data, and my path is indicating this path where our secret will be stored. It is customizable, so you can choose a meaningful path name based on your needs. Then our key value pair. This is the key value pair where key 1 is a key and the value 1 is a value. And our next command is for reading the secret we stored. We use this command to retrieve the data from vault. Here is the syntax. Vault kv get retrieve the secret stored at the specific path, and the my path is shows the path where the secret is stored. Then next command is the delete command. The delete command is used to remove the secrets from the specific path in a vault. Let's look at the syntax. Vault kv delete my path. Vault kv delete tells what to delete the secrets at the specific path, and my path shows the path where the secrets is stored. Then next command is, before we can start storing secrets, we need to enable a custom path in a secret machine. Here is the command. Vault secrets enable path my kv. Vault secrets enable is a and path equal to my is a sets the custom path as a my. And before we can start storing secrets, we need to enable a custom path in a secret engine. Here is the command. Vault secrets enable path my kv. Vault secrets enable is used for enable a path within the secret engine, and the path equal to my sets the custom path as a my, and kv specify that this is the path will be used as a key value store engine. With these basics covered, let's move on to our demonstration. I will run each command and explain it in real time. So let's move to our Ubuntu machine terminal where our Vault server is running. So alright, let's begin our demonstration. First, we will enable a path within the secret engine. I have already started the Vault server in a development mode, so we are ready to go. The first command is to enable a path storing secrets. The first command is to enable a path for storing secrets. So let's move to our GitHub repository for reference. And here is our GitHub repository. Also you can see here all the commands which is used in our video. So I will copy the command and let's go to the terminal and paste over here and hit enter. As you can see, we get success message which confirm that our path is my has been successfully enabled in our secret engine. This step is essential to ensure Vault knows where we intend to store our secrets. Now let's move on to the writing data, or what we can call storing a secrets. So the command we will use is, so let's go to our GitHub repository, and here it is our command for writing our data. So I will copy the data. So I will copy the command and paste over here and hit enter. And as you can see in the command, the vault kv put is used for signifying that we are adding a new secrets to a vault. And the my path, this is our chosen path for storing the secrets. And the key value pair represents the actual secrets where key 1 is a key and the value 1 is a secret value. And also you can see here the success message that confirms that the data has been written to my path. We have successfully stored to our file secret in a vault. Next, we will retrieve the data we just stored. The command for the reading is simple. Vault kv get my path. So I will copy that and paste over here and hit enter. Running this command will display the stored key value pair, showing us key 1 and its associated value. This confirms that our data is securely stored and retrievable in a vault. As you can see here, the key name is key 1 and value is a value 1. And Vault also allows us to view a secrets in a JSON format, which is useful for automation or integration with other applications. The command is vault kv get format JSON and path. So I will copy here and paste over here and hit enter. This command will output the data in JSON format, making it easy to use in a script or for any API based integration. As you can see the output in a JSON format. Now before we deleting, let's take a look at the all available paths within our secrets engine using the vault secrets list command. So I will type vault secrets list and hit enter. So I will write vault secrets list. This command shows all the paths enabled in vault, including the default path like secrets and SOS. Here you can also see our custom path my, which we can enable earlier. Now we will delete the secrets we stored. To delete it, we use the following command. So I will type vault kv delete and type path my path. Vault kv delete specifies that we are deleting a secret, and my path specifies the path where we stored our secrets. So running the command gives us a success message confirming that our secret has been removed from the path. My path location. As you can see here, the message success data deleted. Now to verify that the secret has been deleted, let's try reading the data at the same path again. This time we should see a message indicating that no data is found. So let's run the command. As you can see here, the no value found at my path. After running this command shows a no value found message confirming that the secret has been successfully deleted from our vault. And that's it for today's video. We have covered all the key operations for managing secrets in a vault using CLI. It means command line interface. You now know how to enable paths, write, read and delete secrets with a confidence. In our next session, we will dive deeper into the secrets engine and explore how to enable and manage different types of secret engines, such as the AWS secret engine. So thank you for watching and see you in the next video. Hello everyone, welcome back. In today's session, we are diving into one of the core features of HashiCorp Vault, the secret engine. HashiCorp Vault has a powerful integration with major cloud providers like AWS, Google Cloud, Oracle Cloud, and Azure. Plus, you have the option to store custom credentials, making it a flexible tool for securing secrets in a multi-cloud environment. To understand secret engine better, picture them as a plugin with a HashiCorp Vault. These plugins allow Vault to store different types of credentials. For example, if your project needs access to a Google Cloud, simply enable the Google Cloud secret engine in a Vault. Then Vault provides a secure place to store your Google Cloud credentials, all within the same Vault instance. In this session, we will go over some basics commands to help you manage the secret engines. We will cover how to list, enable, and disable secret engine with your HashiCorp Vault environments. Let's jump into the terminal to start the listing the available secret engines. So let's go to the terminal of your Linux terminal. So first, let's list all secret engines configured on our Vault server. The command to do this is a Vault secret list. This command displays all the paths associated with the secret engine on the server. So I'll type Vault secret list and hit enter. As you can see, there are some default paths included by Vault, such as identity, secret, and SOS. There are a pre-configured path provided when Vault is a first setup. If you have created any custom paths, like I have here with the path my, they will show up here too. And also you can copy the commands from our GitHub repository here. As you can see here the commands. And I will provide the GitHub repository link into our description box. Now that we know what secret engine are already enabled, let's go ahead and enable a new one. For this demonstration, we will enable the AWS secret engine, which allows us to secure store AWS credential within Vault. To enable a secret engine, use the command. So let's go to our GitHub repository and copy the command Vault secret enable path and AWS and paste over here. To enable a secret engine, use the command Vault secret enable, followed by the path and the type of secrets you want to active. Here we will enable the AWS secret engine on the path AWS. So I will hit enter. Once enabled, we can verify by running vault secret list. And also you can see here the success message, success enabled the AWS secret engine. So for the confirmation, I will type vault secret list and hit enter. This should show us our newly enabled AWS path among the other secret engines, as you can see here. And here you will see the updated list now include our AWS secret engine. The AWS path is successfully enabled and ready to secure manage AWS credentials. Now let's discuss disabling a secret engine. Sometimes you may no longer need to specify a secret engine. Now let's discuss disabling a secret engine. Sometimes you may no longer need to specify a secret engine, or you may want to remove custom paths. Let's go through how to disable an existing secret engine. To disable the AWS secret engine, we will use the command vault secrets disable and follow by the path name. In my case, the path name is AWS. So I will type AWS and make sure to use the correct path name. Otherwise, Vault won't know which secret engine to disable. So I will hit enter. As you can see, we received a success message indicating the AWS secret engine has been disabled. Running Vault secret list again. So I will run Vault secret list. Will confirm it's no longer in our list. As you can see. And that's it. We have successfully covered how to list, enable and disable secret engines in HashiCorp Vault. In the next session, we will dive into dynamic secrets, where Vault can generate secrets on demand based on IAM. In the next session, we will dive into dynamic secrets, where Vault can generate secrets on demand based on IAM roles and policies in AWS. This will be especially useful for managing temporary credentials and enhancing security. Thank you for watching and stay tuned for more HashiCorp Vault insights. Hello everyone and welcome back to the channel. In today's session, we will explore exciting features of HashiCorp Vault. Is dynamic secrets. Previously, we discussed secret engines and enabling them in a vault, specifically focusing on AWS. Today, we will go further by creating dynamic secrets for an AWS account, a secure automated way to generate temporary credentials for specific roles. To start, there is a one key prerequisite. You need the root user's AWS access key and secret key. These credentials are essential to configure Vault to generate dynamic AWS secrets. Once you have those, we will enable the AWS secret engine path in a Vault to get things rolling. Here is how to enable, and also you can check out this GitHub repository, and I will provide the GitHub repository into my description box. All the command I will provide it into my GitHub repository, so you can easily copy and paste into your terminal. Now, here is how to enable the AWS secret engine path. So I will copy the command and let's move to our terminal and paste over here and hit enter. After running this command, also you can see the success message of enable the AWS secret engine. Now, we can confirm the AWS secret engine path is active by listing the secrets. So I will type vault secrets list and hit enter. As you can see here, our secret engine is created on path AWS and there it is. Our AWS secret engine is enabled. Next up, we need to set the AWS root config. This config allows Vault to manage temporary credentials on our behalf, and it requires the root access key and secret key and region information. Using the following command, we will configure the Vault with our root AWS credentials. Remember, replace the placeholder access key, secrets key and region with your actual AWS configurations, with your actual AWS credentials. So also you can copy the command from here. So I have already copied from my clipboard. So I will copy command and paste over here. Once we have executed the command, Vault successfully store our root configuration. And note it down, the access key and secret key is very confidential. So do not share with others. With the root config in place, we can now create a role to generate dynamic credentials. Let's set up a role name for managing EC2 instances with permission to perform all actions. Now I am running the command to create this role. So let's move to our GitHub repository and copy the command and paste over here and hit enter. Notice the success message confirming that my EC2 instance role has been added to Vault Secret Engine. Now we are ready to generate our dynamic secrets for the my EC2 role. Dynamic secrets are temporary and will expire after set duration, improving security by limiting the credentials lifespan. In my terminal, I am using the vault read command to generate the access key and secrets key dynamically for my EC2 role. So let's move to our GitHub repository and let's copy the command and paste over here and hit enter. The output show our new AWS access key and secret key along with their least duration. As you can see, the least duration is 768 hours. And also you can see here access key and secret key are dynamically generated. Here we can see the credential will be valid for the specific time before expiring automatically, which is excellent for security. Let's say you want to revoke these credentials before they expire. You can do that by using this list ID associated with the dynamic credentials. Simply run the vault list revoke command with this list ID to instantly invalidate the credentials. So let's move to our GitHub repository and copy the command and paste over here. Copy the command and paste over here. Now replace the list ID and copy the list ID and paste over here. Here is the mistake because I have copied into my clipboard the another command. So forget it and let's run the command and hit enter. Once revoked, the access key and secret key for this list ID will no longer be usable, ensuring total control over your credentials. And also you can see the message, all revocation operations queued successfully. And that's it for generating dynamic secrets in AWS with HashiCorp Vault. Dynamic secrets are a fantastic way to increase security by limiting access duration for each generated credentials. In our next session, we will cover token authentication in a vault to further enhance your security strategy. And thank you for watching and I will see you in the next video. Hello everyone, welcome back. Today we are diving into the token authentication in HashiCorp Vault, an essential aspect for secure vault management. We will also explore GitHub Authentication, another powerful feature that can streamline secure access to your vault. Let's start with token authentication. For the vault, the user needs valid credentials, specifically a root token to authenticate. A root token is generated when you start Vault in a development mode. And here is the terminal after starting Vault. You will find the root token listed here. Copy and save this token. It's your access key to the Vault. To log into Vault using this root token, switch to another terminal and use the command. And first I will copy the root token and let's move to the another terminal and use the command Vault login. So I will type Vault login and hit enter. Now you will be prompted to enter the token. So let's copy the token and paste over here and hit enter. You will see a success message confirming your authentication and now you have to access the vault. And as you can see, the policy is assigned to the root and token policy is root. And here is our token. Now, what if you forgot to save the root token at startup? Don't worry, you can regenerate it anytime with the command vault token create. Also, you can see the commands from our GitHub repository. So, I'll copy the command and paste over here and hit enter, which will produce a new root token for you. Remember to verify that the token policy are set to the root to avoid access issue. Once created, copy the token and use it to log in with the vault login as shown before. As you can see, our new token will be generated. Now let's check it out. So I will type vault login and hit enter. Now I will copy the token and paste here and hit enter. As you can see, successfully we can authenticate it now. The message will be shown success, you are now authenticated. The token information displayed below is already stored in the token helper. So we don't need to run Vault login again. Future Vault requests will be automatically use these tokens. Now if we have generated multiple tokens and need to revoke one, use Vault token revoke. This command will permanently disable the specific token. So let's move to our GitHub repository and copy the command and paste over here. Now replace the token with your actual token. So I'll copy the token and paste over here and hit enter. As you can see, we have successfully revoked token. Now let's run command vault auth list and hit enter. And as you can see, our one token will be shown. So now let's talk about GitHub authentication. So first I will clear the screen and hit enter. Now let's talk about GitHub authentication, which allow users with GitHub accounts to log into Vault. This process is similar to using third-party service like Google or Facebook to sign up for another platform. In this setup, GitHub serves as our authentication provider. You will need a GitHub account, an organization within it, and a team. Here, I will walk through the setting of a new organization in a GitHub. Now, we need to enable the GitHub authentication in Vault. To do this, run the following command to activate GitHub as an authentication method. So, let's move to the GitHub repository and copy the command and paste over here and hit enter. Now, as you can see, success. Enable GitHub authentication method at GitHub path. Once enabled, now let's check it out. So type vault auth list and hit enter. You will see GitHub listed alongside token in Vault authentication methods. Now we will configure GitHub in a Vault by linking to our GitHub organization and team. First, let's create an organization entry in a Vault that matches our GitHub organization name. So let's move to our GitHub repository. And here is the command vault write auth GitHub config organization name vault demo *cloud hub. You can change it according to your needs. I will copy the command and paste over here and hit enter. Now, as you can see, the success message will be shown. Data returned to auth GitHub configuration file. Now we map our team specific permission with Vault. The command below assign the default and application policy to our team, giving them specific access rights. So let's move to our GitHub repository and copy the command and paste over here. Now I will change your team into my team. So I will replace the name my team and hit enter. Now as you can see, the success message will be shown. Data returned to auth GitHub map teams my team. Now we have successfully created our organization, which is Vault demo *cloud hub, and we will set up the team, which is my team, and assign the policy default. Now let's clear the screen. So our next step is to let's move to our GitHub repository and log into Vault using GitHub access token. So I will use the command. I will copy the command and paste over here and hit enter. Now it will ask GitHub personal access token. So let's go to our GitHub page and then let's scroll up. Then select the profile and navigate to settings. Then scroll down and you will see the developer settings. So click on this and here is the personal access token. We need to generate our personal access token. So I will create the tokens. Now I will click on the generate new token classic and I will enter name for Vault demo token. And also you can set the expiry time. So I will keep defaults as a 13 days. So let's scroll down and select the admin for full access control for organization and teams. Now let's scroll down and generate a token. Now I'll copy the token and let's move to our terminal and paste over here and hit enter. After entering your token, you will see a success message confirming GitHub authentication. You are now authenticated with the vault using your GitHub account. Now, as you can see the success message, you are now authenticated. The token information displayed below is already stored into the token helper. Also run the command vault auth list. And also you can see here our token will be root token, and here it is our GitHub token. Now, to remove GitHub as an authentication method, use the vault auth disable GitHub command. So let's move to our GitHub repository, scroll down and copy the command and paste into the terminal. Now, I will hit enter. Now, you can see the success message. It will disable the authentication method from the GitHub path. Now, running this command reset value back to the token only authentication. Also, you can check the vault auth login and hit enter. So, I will done one mistake. So, I will type vault auth list and hit enter. As you can see, the GitHub path will be disabled. In today's session, we will cover root token authentication and GitHub-based authentication in Vault. These methods provide flexibility and control over Vault access. In our next session, we will dive into managing policy in Vault, allowing even final control over user permission. And thank you for watching. I will see you in the next video. Hello everyone, welcome back to our channel. Today we are going to explore the world of HashiCorp Vault, focusing on managing policy effectively. We will go through each command step by step, and let's start the journey. Before the beginning, as you can see here our GitHub repository, and here is the listed all the command which is used in the video, and I will provide the GitHub repository link into my description box. So go to it and let's get started. To begin with, let's go to our terminal and let's see what policies are already existing in your vault. It's like checking what rules are already there before you add new ones. So type the command vault policy list, and also you can copy the command from our GitHub repository from here. Now this will show you a list of all policies, including default ones like root and default, plus any other you might have added previously. Now we will write a custom policy. Think of this as a setting up new rule for who can access what in your vault. Let's move to our GitHub repository and copy the command and paste over here, and also the copy command and paste over here, and here it is the following policy definitions. Now hit the enter. Now as you can see the success message, success upload policy, which name as my policy. To make sure your policy is correctly written, let's verify policy by typing vault policy list and hit enter. And as you can see here, the new policy has been added, which is my policy, and I will enter name is my policy here. Also you can change according to your needs. Now to make sure your policy is correctly written or not, let's read its detail. So I'll type vault policy read and our policy name, which is my policy, and hit enter. To see the specific of my policy, this command will display the permission and path defined in the policy, and as you can see here the details. Now you should need to remove a policy, for example if it's not longer necessary, or to clean up. So we need to use the command delete instead of read. Here it is the same command as per read command, but the one change is delete. Now in this video I am not deleting the policy because I have used for next video. So here it is a reference for vault policy delete to deleting our policy. Now let's link a token to our newly created policy. This step is crucial as it enables our application of policy users operation within Vault. So let's go to our GitHub repository and copy the command for attaching a token to a policy. So copy the command and I will paste here and hit enter. These commands create a new token, assign it to my policy, and sets it as an environment variables. Now let's clear the screen. Before we proceed to associating an authentication method with our policy, let's store some credential using the secret engine to demonstrate how your policy interact with actual data. To store a password, let's go to our GitHub repository and copy the command storing credential using your policy. So I'll paste here and hit enter. This command places a password under the path secret creds. As you can see here, controlled by your KV secrets engine. Now let's go to our GitHub repository. Now to use our policy effectively, we need to integrate it within an authentication method. Today we will configure an app role. So first of all, we need to enable the app role. So I will copy the command and paste over here and hit enter. As you can see the success message shown, which is success enable app role auth method at path app role. Now we will successfully configure our app role. So let's check it out. Vault auth list and hit enter. Now as you can see here, our new path will be stored here, which is for app role. Now we have successfully configured an app role and link it to our policy. And here is how to do it. So let's go to our GitHub repository and copy the command for associating auth method with policy. So I will copy the command and paste over here and hit enter. And here we can done one mistake. So let's fix it. First of all, we clear the screen and hit enter. Let's go to our GitHub repository and copy the command and paste over here and hit enter. Now as you can see, our data will be successfully returned into our auth app role into my role. This configure the app role name my role with the specific token and secret ID behaviors, linking it to my policy. As you can see here, it will link to the my policy. I will enter the name as a my role. So it will successfully linking it to my policy. Lastly, let's generate and export the role ID and secret ID for my role. These IDs are necessary to authenticate using these roles. First, to generate the role ID, so let's go to our GitHub repository and copy the command and paste over here and hit enter. Now next, to generate the secret ID, and I will copy the command and paste over here and hit enter. Now this command will run successfully, and these commands will store the IDs in environments variable for easy use in script or applications. Now let's go to our GitHub repository. So now we have generated the role ID and the secret ID. We are gonna just perform some, or we are just going to write some configuration using this role ID and the secret IDs. So this is the command which we are going to run. So I will copy the command and paste over here and hit enter. Now as you can see here, our token and our policy will default and my policy. And also you can see here the role name, which is my role. So thank you for watching. We will cover a lot from creating policy to securing your vault with authentication methods. I hope this tutorial was informative and helpful. So stay updated with our latest tutorials. See you in the next time. Hello everyone, welcome back to this session on deploying HashiCorp Vault in a production environment. Today we will transition from a development setup to production ready deployment of Vault. I will cover everything from shutting down development mode to creating our configuration file, setting up a storage backend, initializing Vault, unseal it, and finally accessing the UI on an AWS instance. So as you can see here, our GitHub repository, and I will provide all the code and I will provide all the commands and code over here, and our GitHub repository link I will provide it into our description box. So let's get started. First, let's stop Vault server in a development mode. So let's go to our terminal, and as you can see, we can started our server into development mode as usual. So let's stop it by Ctrl+C. Now our development mode is a stop. These steps prevent any conflict when we set up a production instance. Open the terminal where Vault is running and press Ctrl C to shut down the development server. It's easy, right? Then verify it has stopped by running the command Vault status. So I will type Vault status and hit enter. As you can see, our Vault server has been disconnected. Now, you should see a connection refuse message indicating that the development server is no longer active. To ensure no development credential interfere, reset the Vault token by running the following command. So let's go to our GitHub repository and copy the command to reset the Vault token to clear any conflict development credentials. So I'll copy the command and paste over here and hit enter. This unsets the development token and clear any lingering credentials. Now we will create a configuration file named config.html. To verify Vault's production settings, use the command search config.html and hit enter to create the file. Now let's check it down. So I will press ls and hit enter. As you can see, our config.html file will be created. Let's add the necessary configuration for our production setup. So open a config.html file by typing vi config.html and hit enter. Now let's go to our GitHub repository and copy the following command. The following command indicates the storage indicates define wrap storage for persist data storage at Vault data. As you can see here, the path and node ID is node 1 and we will set up the listener TCP. We will set up the TCP listener at localhost. TLS is disabled for this example. Now we will provide an API address and cluster address over here, which specifies API and cluster endpoints. And the UI enables the Vault web interface. Now I will copy the command and paste over here. Let's press escape button for exit and save. So I'll press escape button and press :WQ and hit enter. Now we will successfully exited. Next, create the storage directory for the Raft backend. Run the command. So let's go to our GitHub repository and scroll down and copy the command for creating Raft backend. So I'll copy the command and let's go to our terminal and paste over here and hit enter. This directory will store all Vault secret and data, ensuring persistent across sessions. Starting Vault with the config file. With our configuration in a place, start Vault server using the command. So let's go to our terminal and scroll down and copy the command. It is for Vault server -config and our configuration file. In the previous one, we will start server as a Vault server -dev flag. So I'll copy the command. This command initializes the Vault with the specific production settings. To run this command, the Vault is running in a production mode. So I'll copy the command and paste over here and hit enter. Now our Vault server has been started into our production. This initialized Vault with the specific production setting. Vault is now running in a production mode, though still in a sealed state. Now to make sure the client can communicate with the Vault server, export the Vault address by running. Let's go to our GitHub repository and copy the following command. So I'll copy the command and paste into the another new terminal. So I'll paste into the terminal. So I'll hit enter. This points the client to our Vault server, a necessary step before initializing and unsealing Vault. Now next, initialize Vault with the command Vault operator init. So let's go to our GitHub repository and copy the command Vault operator init and paste over here and hit enter. Now this command generates the unsealed keys and the root token, which are critical for accessing and managing Vault. As you can see here, the unsealed key and root token here. Make sure to securely store these keys and the root token. So I'll copy the unsealed keys and root token into my notepad. So I'll paste here as they are essential for further access and management. So let's go to our GitHub repository now. And our next step is to Vault starts in a sealed state, meaning that even though it's running, data is inaccessible. To unseal it, we can use the command multiple times in our unseal keys. So as you can see here, but for this demonstration, I will not use this command, and I will show you the UI, and I will show you the alternative way, which is the Vault UI to unseal the vault for more interactive experience. Now let's open our AWS EC2 instance page. Now our Vault server is deployed on an AWS EC2 instance. We will access it by using its public IP address, as you can see here. Now let's go to our GitHub repository and copy the following command and open a new tab and paste over here. Now replace the public IP into your actual IP address. Now I will copy the public IP address and paste over here and hit enter. This brings up the Vault login page. Now enter the unseal keys in the UI, one at a time. Now as you can see, it will ask for unseal key. So let's go to our terminal and copy the unseal key and paste over here and paste to the unseal. Now it will successfully done. Now it will ask for 2 more keys. So let's go to our terminal and copy the key and paste over here and hit enter. Again I will provide 1 key. So let's go to terminal and copy the key and paste it and unseal. Now it will successfully redirect to our signing page. Now to signing, we need to enter the token. It means root token. So let's go to terminal and copy the root token and paste over here and hit to the signing. Now we are successfully logged into our Vault UI. Now inside the Vault UI, you will find the various sections managing secrets, policies and configurations. This interface mirrors many command line operations but provide a more interactive experience. And that's it for the video. Let's conclude our tutorial on deploying HashiCorp Vault in a production mode. In the next session, we will take this further by integrating Terraform with Vault on AWS, automating secrets generation and storage in a Vault. Now, thank you for watching. See you in the next session.